Hello, welcome back to my channel. Today let's try another Leetcode problem, number 14, longest common prefix. The problem is easy to understand, so here I will use two different ways. So one is an easy way, because this is an easy question. Another is I will use a medium way. I will use try to solve this kind of problem, because longest common prefix, normally when we are solving with prefix and it is letters, we can use a try. So first of all, I will use the easy method to solve it. As we can see, like this is a flower, flow, and flight. The output is FL because FL is the longest common prefix. How can we find this FL? We can take out one word of the strings and check one by one if it is started with a flower. No, it's not. What about take out the R? What about take out E? It's not. Take out O, FL. So each letters start with FL. So we can see that, yeah, the result will be FL. So for others, it's also the same. So for this one, there's no letter start with even one letter D, R, or C, so the result is an empty string. Now let's just code it up from here. So I will return my result. The result will be the first word of the strings. You can define any word. It is also okay. And we can check that if for word in strings. So for each of the word, while not, yeah, if it not start with the whole word, we will minus by one, take out this one. While not word dot starts with, in Python you can use this to check it easily. And this algorithm starts with also takes on time, and here also takes on time. So this time complexity should be on square, and n is 200. So it is like 40,000. Normally we can pass the normally we can pass it. Let's try. If it does not start with result, so the result will be cut the last letter, result here -1, and we can return the result. I think 5 lines code is enough to solve this kind of a problem, because we just needed to take out one word and check one by one. Yeah, as you can see, it works and it is very fast. Now let's try another method. So why we need to try another method? Just use this one. This one is okay. But try is used in a lot of Leetcode problems. I think you need at least know what is a try, what is the structure. You need to write out the data structure and try to use it for the simple problem, and then you can try to use it in some medium and hard problems. Now let's try to use it in this problem. So let me tell a little bit about the try. If you want to know a little bit, you know, basically the data structure, you can search a lot of YouTube videos. They are good tutorials you can learn. But for this problem, I will use the try structure like that. So here I will define try node. So in the try node inside there's children. Children is I will use a dictionary, and it will have a add of a word. I will use false. I will use false. So this is try. So for example, this one AB. So here from the root, it will put AB inside. ABA here from here will already have B, so we put ABA inside. This kind of a data structure, when you build a try, it takes time. But when you search a word, if this word is inside a try, it only takes the less of the word time. Normally it's on time. So this is why we always use a try to solve the problem of a prefix, longest common prefix. Now let's try to use the try method. First of all, I will define a trie node. So let's define a trie node class, and inside the node, let's init some variables. So there are two variables. One is self.children. Self.children is a dictionary. Yeah, so because the trie data structure is similar to trees, but for tree we will use tree.left and right because there are only two nodes. But for trie it can be many nodes. For English letters, for maximum it will be 26 nodes. So you cannot use trie.node 1, 2, 3. You don't know how many there is. So you should use a data structure dictionary. Yeah, because you put everything inside this children. And you also need to define a self add of a word. This will check if this is the add of a word. For example, if this here flow when it goes to this W, you know from here it is the add of a word. Yeah. You can use many other different structures, but you need at least know one data structure because yeah, it's like a template. When you finish the template, you should not change it all the time because it's a lot of code. Basically, you need to remember how to write this data structure, and then you try to use it to solve the different kind of problems. Now let's try to define insert for. Now let's define the trie node. We've already defined the trie node. Now let's define a trie. First, we put the root. The root will be a self.root of the trie will be just this trie node. And then we define the insert. I will use insert, and inside it will be word. Here will be self word. Yeah, I will use a variable current pointed to this self.root because later on I will use self.root again to insert every word because it's not only one word. There are many There are many words, so we need to define a current pointed to this self.root for each time of the insert. After define this current node, I need to go through one letter by one letter inside this word. So for the character in word, we need to check if this character is inside the children or not, because we need to go through the trie one by one. Like from here, we need to go through one by one from A to B. Yeah. So we need to, for C in word, we need to check this letter if C in current dot children. If C not in, if it is in, we can just put the current to the next. If it is in, so the current equals current children C. But if it is not, we should initialize the trie node. So the current dot children C should equal to this trie node. Yeah, because if this letter is not inside current dot children, there's nothing inside. And the current dot children is a dictionary. You need to put this letter inside the dictionary. And this letter's value is the trie node. Yeah. And inside it is also a dictionary and with add of word. Yeah. And here, if you already insert everything, so this is it's not inside. Normally, even it is not inside, you should first define this trie node, and you need to shift your current to the next. For example, if it is here, yeah, you need to shift it to the next B. And at the end, you need to current dot add of a word. You need to put this to true. Before it is a false. Now you know after insert of one word, you need to put a true at the end of the word. So this is the definition of try and insert. I will not define any other things because it is not necessary for this kind of problem. Now I can use my try here, use the data structure. Try equals try, and for word in strings, we need to insert it to the try. So try dot insert word. After you insert the word, you can return the result. So what should be the result? I will define a result as empty string, and finally I will return my result. So in between, I will use a current. So the current will be pointed to the try node. So the current will equals to this try. Here I have a try dot root. The current will point it to its root. We can use a while current, which we will check if there's any letters inside this current dot children or not. If while current, it means this current exists. If current, if less current dot children, yeah, it means if there are more letters. For example, if it is like yeah, let me find it. Yeah, if it is like this, AB, we can return the false directly. We can return an empty string directly because there's no common letters. So we need to first check the less. The less is like this. Yeah, or the less is like this. So if less is more than 1, or current dot add of word, if it is already an add of word, we need to break the while loop and return the result. Yeah, but if it is not the condition, we should go through one by one. For example, here, it means that we don't have this branch, we only have this branch. We need at least to go to A, and then go here, we may stop, and A will return, and the result will be A, like this kind of try data structure. Yeah. So the current addable word, it will break. So how should we go through with that? Here I will use iterator because iterator is much faster. Here, because we've already, if it is more than 1, it will break and return our result. Here means its children is only 1. So here I will use the iterator, while iter current dot children. It will only return a 1 letter if it is inside. So this will return a letter of A. So A will be here. So the C equals to the letter A. Next iterator is children, because here is inside its children is a dictionary. Inside of the dictionary, there's only 1 K for this case, because if it have more than 2 Ks, it will break and return the result. Yeah. And result should plus this letter. After that, we need to shift this current. Current should equals to current dot children C. So this basically is the entire code. Let's run it to check if there's any other syntax problems or typo. Yeah, it seems okay. Now let's submit it. Yeah, as you can see, yes, it works. But the the speed is a little bit slower. But when you analyze the time complexity, you don't need to consider about here the speed. It doesn't matter, because for here when you use a trie data structure, you put everything node inside and it's like a node of a node. It takes time. But when you analyze this data structure, it saves time. Before, as I analyzed, the time complexity is O(n) squared. But when you use a trie, you need to insert each word. You have how many words? You have maximum 200. What is the last maximum? It's also 200. So here, when you insert for a trie, the time complexity is also O(n) squared. But when you search from here, when you finish your insert, when you check, when you check if it is the first, if it is FL or something, it saves you a lot of time. So the trie data structure is not good for a lot of insert. But if everything is determined like a dictionary, you just need to search this word. It takes only O(n) time. So n is the less of word. But the time complexity from here, it is only the less of the word. If the word is constant, so it is O(1). But here for this insert, it takes some time. Yeah. Thank you guys. Thanks for watching. I hope you understand the trie data structure and you can try to use it in different places. Thank you for watching. Bye. See you soon. If you like my video, please like and subscribe. I will upload more Leetcode problems like that, and later on I will upload more trie problems like this. Thank you. Bye.